And today's section is all about graphing f of x is equal to a multiplied by x minus h squared plus k. So this is really similar to ax squared plus c. We're adding an h here and replacing the k with a c. So we're still going to be graphing a parabola. Before we get started into that too much, I want to take a few seconds to talk about even and odd functions. A function is even when f of negative x. So if you plug in the negative of x, you end up getting a the original function back. So you end up getting f of x back. And it's symmetric about the y-axis. And so that's an even function. And then you can have an odd function, and a function is odd when f of negative x ends up resulting the entire original function making that negative. And so that's going to be symmetric about the origin. And this is going to be one of those things where you just have to kind of see an example, because using this f of negative x equals f of x is a pretty vague term when you're not that familiar with it, especially as an Algebra 1 student. So why don't we first identify some even and odd functions. So if we take this first function here, f of x is equal to 2x, and everywhere we see an x, we plug in a negative. So all those parentheses, we're going to plug in a negative x. All right. So this is going to be f of negative x is equal to a negative 2x. Notice that negative 2x is actually equal to the negative of our original f of x. So this function is odd. All right, we can have another function like g of x is equal to x squared minus 2. And so if we plug in a negative x everywhere we see a square, or sorry, an x, that's going to look like that. We'll plug in our negative x's. All right, and this is going to be g of x is equal to a negative x squared is just going to be a positive x squared minus 2. And notice that's the exact same as our original g of x. So g of a negative x is equal to g of x. That's going to be the function is even. And now just one more, we could have something like h of x is equal to 2x squared plus x minus 2. And if we plug in a negative everywhere we see an x, so we're going to plug a negative into all of these different parentheses. So it's going to be negative x there, negative x there, and then negative x there. This is going to look something like the following. H of negative x is equal to 2. Negative x squared is going to be an x squared. Plus the negative x will just be minus x and then minus 2. Notice that this doesn't resemble the first function at all, because this plus sign right here got changed to a negative. But this original x squared stayed positive. So this function is neither odd nor even. So a function can be odd, a function can be even, and a function can be neither. All right, so now that we have talked about that, I want to talk about graphing a different way to graph parabolas. So let's go ahead and graph f of x is equal to a multiplied by x minus h squared. And this is really going to give you a clear indicator of what h really is. So if this is our coordinate plane here, and if you plug in h to be 0, you're going to get a normal parabola that starts here on the origin. So you're going to get something like that when h is equal to 0. All right, when h is greater than 0, the term f of x equals ax minus h squared moves h units to the right. So you're going to move to the right if h is greater than 0. Oops. And if h is less than 0, then the function f of x equals ax minus h squared, and your h is actually going to look like plus h, because the negative of a negative is going to be a plus, right? And so it's going to move h units to the left. And so we're going to be over here. So that's going to happen when h is less than 0. Your vertex is always going to be h comma 0, and your axis of symmetry is going to be x is equal to h. So why don't we try graphing one of these things? Let's go ahead and graph now g of x is equal to 1/2 x minus 4 squared. And so our first thing we're going to want to do is actually plot our axis of symmetry. And so if we go ahead and draw a coordinate plane over here, we're going to be mainly over here in quadrant 1. All right, notice that our h in this function is equal to 4. So there's our h right there. And so our axis of symmetry is going to be the line x equals 4. So we're going to go out to 4, and we're going to put a dashed line right there on our axis of symmetry. Next, we're going to go ahead and plot the vertex. And we know that the vertex is the coordinate h comma 0. And so h is equal to 4, so that's going to be 4 comma 0. So our vertex is going to be right there on that yellow dot. And then finally, we just want to find a couple more points to complete our graph. So we're going to find 2 more points. I always like plugging in x is equal to 0 into my graphs because it's a really nice function. So if we plug in x equals 0, so that's going to be g of 0 is equal to 1/2 0 minus 4 is a negative 4 squared. Negative 4 squared is 16, and that is going to be equal to 8. So one of our points is going to be at the coordinate 0 comma 8. So we're all the way up here. And because this is the axis of symmetry, we also know we're going to have a point over there. Unfortunately, we can't really draw our graph quite yet because there's about 1,000,000 different ways that we can make it up to that point. So we need to find another set of points so we can more accurately draw our graph. So why don't we plug in something like x is equal to 2. So that's going to be a g of a 2 is equal to 1/2 of 2 minus 4 squared, which is equal to 1/2 of a negative 2 squared. Negative 2 squared is a positive 4, and 1/2 of 4 is equal to a regular 2. So we have another point at 2 comma 2. And we can mirror that over there. So now we can connect these points like so. There we go. And that's how you graph using this non-standard form, I would say, because most of the time you see a parabola, it's all x squared and ax squared plus bx plus c. But remember, the goal of today's lesson wasn't to just graph ax minus h squared. We want to go ahead and graph a x minus h squared plus k. And this is called the vertex form. And the reason why this is called the vertex form is that the vertex is the point h comma k. And the axis of symmetry is k is equal, or not k, x is equal to h. So why don't we use that knowledge to now graph g of x is equal to negative 2 multiplied by x plus 2 squared plus 3. All right, so we're going to do the same exact steps that we just did. We're going to first find the axis of symmetry. All right, and our axis of symmetry is still based off of x being equal to h. H is right here. Notice that normally the function is a negative, right? We're minusing h. So if you see a plus here, h is actually negative. So h is equal to a negative 2. Therefore, x is equal to a negative 2. And because, I don't know how I just drew a triangle, because we are working now in this negative 2, we're going to work over here on the left-hand side of the graph. And we're also having a negative function, so we know our parabola is going to open downward. So we're going to focus in quadrant number 3, draw a dashed line on x is equal to negative 2. Step number 2, we are going to go ahead and plot the vertex. And we know the vertex is equal to h comma k, and h is equal to a negative 2. Normally k is right here, and k is given to us as a plus form, so k is going to just equal plus 3. So the term in the parenthesis changes the sign. The term outside the parenthesis don't change the sign. And so our vertex is going to be negative 2, positive 3. And so that's going to be up there. Right, I needed to extend this a little bit more. There we go. All right, and now step number 3 is to just find some more points. So I always like to start with x is equal to 0. So we're going to plug in g of 0 is equal to a negative 2. 0 plus 2 is 2. We're going to square that, and then we're going to add 3. 2 squared is 4, times a negative 2 is negative 8, plus 3, or a negative 5. So our coordinate is 0, negative 5. And we know we're going to mirror that over here on the other side. Next, let's pick another point. We'll pick x is equal to 1. So we're going to plug in g of 1 is equal to a negative 2 times x plus 1 squared plus 3. And so this is going to equal, oops, I totally screwed that up inside there, didn't I? This is going to be a 1 plus a 2 squared. 1 plus 2 is 3. 3 squared is 9. 9 times a negative 2 is negative 18. Oh, I know what I'm doing wrong here. I actually want to plug in a negative 1. If we plugged in a positive 1, we're going to be, way down here, and that's not really useful. Let's plug in a negative 1. So g of negative 1 is going to equal a negative 2 times a negative 1 plus 2 squared plus 3. Negative 1 plus 2 is a positive 1. 1 squared is a 1. Times a 2 is a negative 2 plus 3. So g of negative 1 is equal to a negative or a positive 1. So we have another point here at negative 1, positive 1. And we can mirror that over there. And now we just complete our graph.